Here we have two parametrics, the x parametric for the x coordinate and the y parametric for the y coordinate. We need to get the slope-intercept form from these two parametrics to graph it, but these are useful so that we can find, like time values. So say we were measuring this in seconds, we could get the coordinates for this by having the seconds of whatever, like I don't know what, but you could use that. And so to do that, you do 3/4 over 1, or 3/4 over 1 because this is 1t, that you don't see the coefficient when it's 1. And that's because this is the rise and a rise over run kind of thing, and this is the run and the rise over run. So that would be 3/4. 3/4, 3 over 4. X, yeah, x. And then you have this part here, which is where the y-intercept is. So 3 over 4 plus, that's not really working out, plus 3 equals y. All right. Now, it's my partner in crime. We'll show you what to do now once you have that. Even though it's kind of written a bit backwards, I think. I don't know. I can't really tell. But from here, we can get some points with time values. So show it.
So basically, you can input a couple time values and get the slope. So let's just first do -1. So
-1.
ft equals -1, x is -1, and then that means that you substitute t right here, and then add 3. So then that's +2, and then
+3.
Yeah, +3. So
2 1/4.
2 1/4.
Now we can let's do 0 as well.
Yep. So t equals 0, x is 0,
Because,
and then those cancel each other out, so it's just 3.
Or they don't equal anything because it's 0. Well, they equal 0, but that doesn't equal anything. I guess I don't really know what I'm saying.
So then put 1 in here. I'm just going to do that.
Yeah,
because 1, and then 3 and 3/4.
3/4 times 1 plus 3 is 3 3/4. So now we can graph that. Let's just erase that.
Okay.
No, not that. That was kind of useful, but oh well.
Yeah.
So.
Oh, we already know.
So, draw the graph. I can't open this. Can you draw the graph?
Okay. So we're gonna just draw a nice graph right here.
That's the x. That's the not x-intercept. That's the x-axis, and that's the y-axis.
Mm-hmm.
So let's put a couple of lines to mark some points. 1. That's 1. That's 0.
Mm.
That's -1. That's 1. That's 2. That's 3. And that's 4. And that's -1. -2. All right. So the first point is when t equals 0. Let's graph that. We got 0, 3. So that would be here. T equals 0. Next point is t equals 1. So that was when x equals 1 and 3 3/4 is y. So that would be there. T equals 1. And then the next point is at -1, which is back 1 second from the starting, which is 0. So like back maybe 1 minute or 1 second, 1 unit of time. And the coordinate was -1, 2 1/4. So that's there. That's t equals -1. And then you can just graph the path of travel from the slope-intercept form we got earlier, and that's more or less that line.
Perfect.
As you go back, t decreases in value to like negative numbers, and as you go this way, t increases in value towards positive numbers, and so does the x and y. The x and y decreasing this, it's constantly going up. It's constant. There's a constant. It doesn't change. It doesn't get faster. It's linear. Yeah, that's the word.
Sweet.